Distributed Computing with Dahan.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast to deliver quality and to run your software with confidence in Azure, all while using everything the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. They are hiring architects and .NET engineers who'd like a path to become architects. You can go to clearmeasure.com/careers and learn more about ClearMeasure. Software projects are hard, but yours doesn't have to be. Our guest today on the show is Dahan. He is one of the world's foremost experts on service-oriented architecture and domain-driven design, and also the creator of NServiceBus, the most popular service bus for .NET. He also joined us way back on episode 32 here on the Azure DevOps Podcast, where back then we discussed his take on microservices, but he's back with us. Udi, welcome to the show. How are you, sir?
I'm doing well. Thanks for having me, Jeffrey.
Oh, my pleasure. My pleasure. It's been a while since you've been on the show, but even longer since we saw each other in person back in Austin. I think it might have been way back in 2007 for the AltNet Conf, unless my memory's...
Oh, my goodness. That's 15 years now. You realize how old that makes us now?
Yeah, well... Yeah, but we were that was that wasn't the beginning. We both started in the late 90s or so. So yeah, we're kind of old compared to half the programmers in the market now. Mm-hmm. It's all good. It's all good. Yeah, a lot's gone through, and particular continues to grow. But we'll let the listeners go back to episode 32 and kind of catch up to get to know you more. But we talked about microservices last time, and you've kind of been around the block multiple times on distributed computing and messaging and service buses and all that. What are the high points? Catch us up in the last, I don't know, let's just ignore the last 10 years. In the last 5 years, what's new in the industry, or what's different when it comes to just the state of distributed computing?
That's an interesting question. I'd say that there's probably a lot more of the same rather than a lot of new things. So if you'd asked me in the last 10 years, I'd say things like service meshes came onto the scene, Istio and the others around it in the open source world. And probably over that time, service meshes kind of, like most other technologies, had a certain kind of hype wave, and then the trough of disillusionment as people realized, oh, this doesn't solve all of our distributed computing problems. So a lot of the problems are really the same. It's almost surprising that every generation of programmers needs to relearn kind of the same points over again. So my guess is because it's I'm going to put myself in the category of the old timers. If I say I have a blog, people will say, "What's that?" Say I'm on Twitter. Oh, with the old people. That you should be on TikTok. And I'm like, I'm not going to go on TikTok. But that's where all the action is now on a range of topics. So because sort of the medium changes, then the fact that, let's say you wrote a book, people say a book, like actual dead trees printed on paper type of thing. Who reads books anymore? So just sort of the changing mediums have meant that the newer generation of programmers are not accessing the knowledge that's been around a long time in the industry, because they're looking for it, or looking for things in different places. And the previous generations we're not as comfortable with change. We've kind of been doing our thing our way for a while now. And for that reason, every generation kind of runs into the same problems, sometimes with different technology sets, feels the pain and then learns the lessons. So I'd say that that if again an adjacent process to your own is actually not that different from application servers back in the day, because that's essentially what, if we're talking on the Microsoft platform, IIS was, right? It was its own process that ran other processes, which is actually your code. So those application servers were actually not that distant from service meshes. Your code would talk through the application server to other pieces of code that were running on the network. And that wasn't so different from, if we talk or not just on the Microsoft environment, we had the enterprise Java beans and the non-Microsoft side of the world. So again, that's, about 25 to 30 years old now. And we're still essentially coming up with new generations of technology that are addressing the same category of problems. And in some ways, the technology is getting better. But I'd say that in many other ways, because the sort of the architectural principles are being relearned, so the idea of let's distribute everything into these tiny serverless functions as a service type things, and people are doing that on AWS Lambda, Azure Functions, and now each of those platforms also has their equivalent of sort of durable functions, durable entities, whatever the specific thing that you call it. And people are all excited about it, or, actor frameworks as well. So what is that? Essentially, it's distributed objects. And that was essentially the lesson from however many decades ago. Where it was right. Distributed objects, that was a bad idea. We tried that. It just did not work out well, because essentially anytime you're doing some sort of more complex logic that needs to touch a bunch of state, then you end up having to flow transactions across all of these distributed objects, actors, durable entities, again, whatever you want to call them. And but nowadays, the technology actually isn't there. We don't have distributed transaction coordinators that are implemented for these types of things, or XA transactions that can talk to each other in an interoperable manner. So developers these days are not given any tooling to solve the how do you keep distributed state consistent. They've essentially inherited the ideas of eventual consistency is fine, without realizing that it doesn't just magically happen that you get eventual consistency. The more likely outcome when you're working in this kind of distributed object style is you end up with eventual inconsistency. It's one failure condition is enough for your system to become inconsistent. And the assumption is, well, the system will somehow eventually become consistent again because we've been sort of pushed this eventual consistency story. But with no tooling to kind of solve that problem, just end up with more systems that end up in inconsistent states.
Which sounds like a mess.
And it is a mess, and users are kind of left with trying to figure out why is it that my data is in an inconsistent state, and then essentially doing all sorts of manual compensation work to solve those problems. So what's new essentially is people struggling with problems that used to be solved by technology and now aren't.
Because the distributed transaction coordinator made the assumption that everything was going to be on a consistent version of the Microsoft components that the DTC supported. as opposed to all kinds of
The
different
main
platforms.
thing was physical proximity.
Yeah.
You're running in a single data center in a bunch of machines that are close enough to each other that essentially they're either going to be all up or all down at the same time.
Mm. Yeah.
And that where we are today is, not the least of which, because of the cloud, many more machines in many more distributed locations without that physical proximity, and therefore the inability for a distributed transaction coordinator to actually do its job, which is why Azure and AWS and all those folks kind of said it's infeasible to build something like that. I mean, even if we built it, then the system would essentially just sort of lock up, waiting for transactions
right.
to kind of say, yes, I'm done, and we can continue to the next step. So you can kind of tell if the big vendors are saying, and they're building so many services, right? So if you got AWS and the Azure teams who have thousands of developers between them, look at that problem of distributed transaction coordination and say, that's too hard of a problem, we're not going to tackle it. And they haven't been doing that for the past decade, right?
Yeah.
Then essentially the average business developer saying, yes, I'm totally going to build my system out of these distributed actors, entities, durable, whatever, functions, etc. Yeah, how hard could it be for me to keep my state consistent across all of these things? The answer is a lot harder than you think.
Now, define for us, because I think there's a lot of listeners out there that don't really understand this concept, service mesh.
So the idea of the service mesh was that you have a service that needs to communicate with various other services, and there's all sorts of cross-cutting infrastructure needs to be handled. So it could be the serialization, deserialization. It could be rate limiting on the way in, rate limiting on the way out. It could be health checks, any number of things that sort of go on in terms of things communicating with each other, interoperability concerns. So the way that service meshes approached this problem, which was a little different from how it was approached in the past, was they're an out-of-process host that essentially solves those problems. So your code, your service is running in its own process, and the service mesh is essentially sort of it's known as a sidecar. If you can kind of think of the motorcycle and the sidecar, that's the same kind of idea. Your service is the motorcycle, and the service mesh process is a sidecar. It's kind of attached to your service, and it provides that functionality. Why did they do it as a separate process rather than doing it in process? Because it essentially solves the problem of interoperability. So if you have a service written in .NET and a service written in Go and a service written in C++, and then instead of having a separate library for each of those types of programming languages, which is a higher maintenance cost, they thought it would be simpler and better essentially to interop between the service process and the sidecar process using essentially regular interprocess communication, HTTP. So that allowed them to build their service mesh in a singular technology and essentially do all communication HTTP in all directions. Now,
when you say they, who are you specifically referring to when you say they?
Istio, there's Istio and all of the others that were inspired by the service mesh group. I don't think there was an actual standardization around it. I think there was an attempt to do that, but essentially Google Service Mesh, and you'll see a bunch of the others. Again, it's as a term, it kind of raised in hype quickly as people said, mesh, that sounds like a cool thing for me to include on my CV that I don't currently have. So a bunch of people kind of went into it and fiddled with it until they kind of realized, oh, this is just another piece of infrastructure that is kind of finicky, and you need to set it up and you need to deploy it and you need to configure it, and sometimes it works and sometimes it doesn't work, and it's okay, it's not a silver bullet. Okay, then what's the next thing?
Yeah.
So it's
Yeah.
I wouldn't get overly hung up on that. The concern that I always had about the service mesh approach is that there's a certain category of problem in distributed computing that you can't solve when you're running out of process without transactions. So one of the features that we've had in NServiceBus for a very long time is an outbox. Now, what problem does the outbox solve? It's that sometimes, or I'd say it's more often than not in complex business systems, you'll get some message that comes in that is going to invoke some business logic of your own. Your business logic is going to want to update some data in a database of sorts and send out some other messages. Now, the problem is what happens if there's a failure somewhere in that process. So let's say that you update the data in the database before you send out messages. Now, and your process crashes right there. So often what will occur is because people have been spoon-fed the concept of idempotence from the REST folks. That's 10 years before the last 10 years. It's you just need to make your business logic idempotent. So because they didn't finish processing the message the first time, message rolls back, they try it again, and then their logic says, well, okay, I shouldn't just process the message the second time. I shouldn't charge the customer twice for the same order. I'll check in the database if I've already processed this message before. So they'll go into their database and they'll see, oh, yes, we already have a record for that whatever ID that they got in the incoming message. And they'll assume that the processing was fully successful the last time. So they won't emit any of the outbound messages that they need. For example, publishing events that other systems are expecting to hear about.
Yeah. It's a partial failure.
Right. So the database was successful of that service, but all of the other services that were expecting to receive an event or any other outbound messages relating to that, they don't receive those messages. And as far as the logs indicate, it's everything's okay, right? There was a partial failure, there was a retry, it resolved it because we wrote idempotent business logic. But the tricky part is how do you do idempotence that spans a incoming queue, a database, which is usually a different technology, and outbound queues, even if the outbound queues and the incoming queues are on the same message broker technology. And that could be RabbitMQ, Azure Service Bus, Amazon SQS, whatever.
Mm-hmm.
So the thing is that a lot of those queuing technologies, for example, don't give you transactions that span both the ingoing and the outbound messages. So you may have sent out some of the messages, but not all of them. Now, most developers don't know that that's even a problem that they need to address. It's only after you've built and run a system long enough and dealt with all kinds of failures in it that you realize, oh, wait a minute, how is it that system A has this in its database, but system B doesn't, and there are no logs that indicate that anything went wrong, except for maybe like a minor retry type of info message that occurred in system A. And it's only when people kind of trace that down and say, oh, okay, there's this, really weird partial failure case that sometimes happens that they start spelling, saying, okay, how do we solve that problem? And then they uncover this outbox pattern, which essentially provides a mechanism for making the outgoing messages, essentially, it writes them into the same database before dispatching them. So, a problem like that requires that the infrastructure that is managing both the incoming and the outgoing communications is able to enlist and store data as a part of the business transaction. That's a thing you can't do in an out of process type of architecture like a service mesh. So people using service meshes don't know that they're going to have these problems when their systems are running in production long enough. It's you don't know you have the problem until you have the problem.
Yeah.
And then once you have the problem, it's congratulations. Now you've got a bunch of production systems with partially inconsistent data between them. Try to solve that. At the same time that users are still using the systems, because you don't want to shut down everything as you're trying to figure that out. But that's a sort of one example of a category of problem that was known about in the distributed computing space for a long time. And the way to go about solving it was also relatively well known and documented. And there's even some presentation of mine from YouTube talking about all of the partial failures of what you need to do to build an outbox correctly from must have been 15 years ago or so. But it's sort of that category of thing that I'd say is why service meshes as an architectural approach are, I'd say, at best insufficient.
Yeah.
I don't want to say that they're flawed. Say they're insufficient. And unless there is some kind of mechanism to solve that is not have business developers write idempotent code, because that is just it essentially moves the problem. And every time people say, no, I can totally solve this in my business code, my response is, I've been doing this a long time. Believe me, you can't.
There's some people that might be able to, but not the general population of programmers.
Yes, it cannot be solved consistently enough by enough developers over a long enough period of time that makes it a feasible solution. You want infrastructure to solve this kind of thing for you.
Yeah.
So again, that's sort of a long response to what are service meshes? What problems do they are they meant to solve? What other problems don't they solve, and why are those problems important?
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
Now, you mentioned every generation of programmers tends to have to kind of relearn at least a few of the lessons from the past, and certainly with the growth of the industry, we're in an area now where we just have a massive number of programmers who probably never, were not around when DevOps discussions were happening, much less when Agile conversations were happening or service-oriented architecture conversations were happening. And just my general observation, there are a significant portion of the programmer population that is distributing computing just with web services still to this day. And so what do they need to hear when they think, I'm going to do my front end, because Angular and React kind of been popular, and Blazor, and even Blazor, Blazor calls back to the server with web services with WebAssembly. Oh yeah, web service this and web service that, and it just calls and it works, and JSON, isn't it great? What do they need to hear?
I think that the problem is not rooted in what do they need to hear so much as who do they need to hear it from. Okay. So I'd say that there's, in my view, a responsibility on the part of the large vendors, Microsoft, Azure, the Azure Group, AWS, Google, and their cloud. And each of those large vendors tends to have, let's call it, for lack of a better term, solution architect folks that are helping customers with the hundreds of services that are available on those platforms. But I'd say that if you are a cloud vendor and you're saying, use my platform, use all of my services to build your complex business systems, there's a responsibility that goes along with that to kind of say, for this type of problem, then this is how you go about solving it. And they haven't been doing nearly enough of that. I would expect that. First of all, I believe that there's an opportunity for them to step into, or let's say back into, because in the past, specifically Microsoft, but Oracle at the same time, and IBM and others, there was a desire and an attempt to be in a leadership position when it came to software architecture. So it wasn't just a use our tools, use our products. It's a no, we have a bigger view of these types of things and how to solve a wide category of problems. I haven't seen those vendors step into that. And largely they said, we provide all of the building blocks and developers will do whatever they want in order to build whatever kinds of systems they need. And the level of guidance and leadership that is being taken on the part of those vendors, in my mind, is woefully insufficient. Because if they're not delivering that message, then it's they have a much larger bullhorn than I do, or than you do, right? I can go around, and I spent the better part of a decade running around to all of the conferences and going on all of the podcasts and teaching courses. Again, probably trained more than 1,000 people, and via conferences got to maybe tens of thousands more. It's a drop in the bucket.
Yeah.
Compared to the number of developers that are consuming Microsoft content or AWS content, etc. So that there's only so much that can be done. And again, it's not that there aren't people at Microsoft, AWS, Google that can't do this, but it seems like the leadership in those vendors does not view this as important or important enough to address it seriously. And it's unfortunate, and thousands of companies and millions of developers and probably hundreds of millions of users that are being impacted by all of the eventual inconsistency that's happening. They're all paying the price for this. So
that's an interesting philosophical point from just a market perspective. From a business perspective, you can say, okay, do I tell my customers what to do, or do I ask them what they want and then give them what I think I'm hearing them say? And then it kind of depends on the maturity or sophistication of your customer base in that area to actually be able to tell you what they want and know what they want and what they would actually benefit from long term.
Well, I've been doing this NServiceBus thing for quite some time, in particular software as a company now for more than 10 years around that. This is the space that I've essentially made my life's work.
Right.
And I got to tell you, with the various hundreds of people that I've interacted with directly and thousands indirectly, it's been rare for me to kind of get the reaction on the part of somebody that kind of says, "Hey, well, what do you know?" Type of thing.
Yeah.
It's I assume that there are some people that just don't listen to me or think that I'm wrong. That's always the case. But it's however many developers and organizations that you can help, then why not? And for the most part, they tend to value that type of help. It's you've prevented me from getting into a mess that otherwise would have been expensive for me to get out of. Then yes, there is value that accrues. And again, each vendor can find some way to monetize that by whatever services that they offer alongside that. But I view it more sort of on the responsibility side of thing. If you know a thing, if you can help, then you should.
Yeah.
And usually that is compatible. It's with business as a whole. It's what is it? Doing good by doing well, or the other way around? Doing well by doing good. It's there's kind of some saying that goes to that effect. And maybe I'm partially naive, and that model doesn't scale, and there's a reason why none of the big vendors are doing it. But for me, like sometimes people ask, say, what if Microsoft, comes in and does what you've been doing? Like I'd say about time. It's there's certain categories of problems that say that we've been dealing with in Service Bus and getting all of the the little technical bits to line up in exactly the right way. And in some cases, our team has been opening pull requests, whether it's with the Azure Service Bus team or the Amazon SQS team or the RabbitMQ team, say, look, we really need these things to be implemented this way, not for us, not to make life easier for us, but without this, these important guarantees cannot be given to developers building complex business systems. And they need those guarantees because without that, they're going to be building eventually inconsistent systems. So I'd be thrilled if the industry as a whole kind of embraced this and said, right, let's stop having to spin our wheels and every 5 years re-implement that. Or if we're talking about the Azure Service Bus client that has been re-implemented 3 times during that time frame, is to say, well, why do we need to go through this every single time? It's the idea of infrastructure is you're supposed to kind of build it in such a way that you don't have to rip and replace it every couple of years.
Right.
So, I mean, within Service Bus, that's essentially the abstraction for the users that say, we re-implement our code every couple of years on top of all of these underlying clients and services so that you don't have to re-implement your code. But I'd be thrilled if I didn't have to waste cycles on that, and I could build a lot more valuable, higher level functionality to solve them, because essentially the list of things that would be helpful in the distributed computing space is so long.
Yeah.
Because I have another 10 to 20 years of functionality that's already sitting in backlogs. And we're all looking at that and saying, if only we had the time to do this. But this thing broke compatibility, and now we need to spend time fixing that up again.
Well, as we get to the end of our time here, I want to make sure that we tell the listeners about NServiceBus and kind of how it meets the market today. And because I personally have used it in a variety of situations for over 10, however many years, over 10. Mm-hmm. And it's a great product. I know it, but it kind of it's one of those non-sexy things that just kind of sits in the background and does the right thing. It's not something you visually see, or the users have no idea it's under the covers. But tell us, just give us the customer pitch for NServiceBus and how developers can start dipping their toe in the water and give it a try.
Right. So I'd say if you're building microservices, then you need something like this. Even if you're building what would be called a modular monolith that needs to interact with other systems, then on the integration part between those systems, you're going to need something like NServiceBus. The use of HTTP for communicating between whether it's microservices or between systems, it's just so error prone that either you as a developer yourself or whoever is maintaining the system after you or your users are going to be feeling the pain of this. And essentially, this has been proven true by decades of experience and theory in the field of distributed computing. So, NServiceBus essentially takes all of the problems that you never want to have And the challenge is that most people don't know that they're going to have them, so they don't appreciate it until they have it, and essentially prevents them from happening. So it's that ounce of prevention is equivalent to a pound of cure. So, you're building a microservices system. I'd say the current limitation, if anything, is that NServiceBus is still a purely .NET solution. So it's something that you'd use in your .NET services, in your .NET systems. It can talk to any number of other platforms, but if you have a service that's being written in Python, then you can't use NServiceBus inside your Python application. And we occasionally get that request from our users that say, NServiceBus is great. We use it on all of our .NET services. We now have some Python stuff here, some Node stuff over there, and we all of a sudden have to work without it. And then we realize just how much heavy lifting it provides. Please provide us a Python service bus, a Node service bus. And unfortunately, my response is, it's a huge amount of effort.
Oh yeah,
to do this even for just one platform. Sorry, we can't provide it for the others.
Now, are there any pieces that don't work in just a kind of .NET Core or .NET 6 situation that require more?
That require more in terms of infrastructure, or more?
More of the framework. For instance, Blazor WebAssembly and the Maui stuff coming up. Any libraries that are effectively just a regular .NET 6 library, the .NET Core or .NET Standard. That's what I meant to say. .NET Standard.
Right.
Those can go anywhere. So,
right.
Are there any pieces that people need to think about that will need more than just the .NET Standard support?
So it will depend on what pipes you want to use underneath NServiceBus. So if you're using an Azure Service Bus or an Amazon SQS that essentially are these third-party services that communication with them is essentially done over HTTP, then you don't need anything. You'll take NServiceBus and the relevant adapter for SQS, Azure Service Bus, etc., and you're good to go. So we haven't tested it yet, but theoretically there shouldn't be any problem in running it from Blazor, because Blazor can communicate over HTTP with anything, which includes Azure Service Bus. So NServiceBus as a library plus the Azure Service Bus adapter, you can talk to, again, in theory, we haven't tested it yet, should work just fine from a Blazor application as well. I suppose it's more a question of, well, what is the underlying transport that you're using? If you're talking about MSMQ itself comes with its own requirements in terms of full .NET Framework support.
Yep.
So it's where that's needed, then you won't be able to use that type of transport. But it's really a transport question rather than an NServiceBus question. And there's enough options in terms of the supported transports around NServiceBus, again, both on-prem and in the various clouds, that there really shouldn't be any limitation there.
Awesome. Well, fantastic. Well, thanks for coming on the show, Udi. This is my pleasure to have you back on.
Oh, this was great, Jeffrey. Great catching up, and we should do this again soon.
Yes, sir. And listeners, you've been listening to The Software Simplest. Udi Dahan, founder of Particular Software. You can check that out. The main product is NServiceBus and everything around it. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.